Thank you, Mr. Chairman. And again, thank you to our panelists today on this issue. This is certainly something that I have become educated on recently as it affects some of our businesses back home in District 2 of North Carolina. And again, I thank you for your expert testimony in helping us to understand what it is that we're dealing with and why, although it was the legislation and the actions were well intended to direct the Department of Energy as, again, a kind of a good problem, as technology has advanced so quickly, we're finding ourselves in this situation where we now have to modify the path going forward. So, Dr. Hakkarainen, will you please take a moment to, and you did explain in your testimony the difference between the design and use of a typical EPS device compared to that of an OLED or LED driver or converter. Could you just expand on that a little bit more now?
Certainly. An external power supply, such as this device here.
Or this is the example that I've been given as well. So.
It takes household electric current, 120 volts, power from 120 volt supply, and converts it typically to a DC voltage, to 5 volts, 9 volts, something like that. And there's a single stage of power conversion in that process. In an LED driver, there are two stages of power conversion. First, we convert to from the AC power supply, which could be 120 volts, but it is often actually 277 volts in commercial buildings, and converts that to a relatively high voltage DC power bus, as we say, inside the driver. And that is then further modulated to operate operate the LED lighting properly, to essentially to drive the LED lighting. So there are two stages of power conversion. In addition, these modern LED drivers have other features as well, such as being connected to to the external world, to the building infrastructure, to the internet, for example. So there are additional features here that external power supplies typically don't have.
So again, and I've got mine as well. So this driver, basically, and we said converter driver, actually does more than that. And so basically it's stationary, it's in the ceiling, providing the power supply for the lights themselves, the LED lights. And so I just want to touch on the issue of the commercial component to this, because to me, one of the big issues here is the uncertainty that our manufacturers are experiencing, but then you can see how it impacts any commercial development and the cost as well. I could see that this could be very, very costly. Am I correct in that?
It would certainly be costly. I'm not even certain that it would be possible.
Possible. And I did want to touch on that as well. I know Ms. Amon had discussed this, but basically as it is right now, the way the EPS rule stands, there really isn't a way to have a standard test procedure. Is that correct? And this will dramatically affect technology moving forward.
Correct.
Correct. And Dr. Hakkarainen, is it fair to say that by encompassing LED and OLED drivers into the final EPS rule, that it could potentially be, we're basically saying that this is going to be counterproductive to the whole process, correct?
Yes, that's correct, because if LED and OLED drivers are not available, then the energy efficiency of buildings decreases.
Decreases. Well, I just, Mr. Chairman, I yield back. I thank the panel so much for their input and their testimony and your expert ability to help explain a very difficult technical process so that we can create better legislation and be working with our business communities. Thank you so much.